We're back. Okay, so I was in the help for ArcGIS. Okay, looking at a search cursor. So we're looking at a search cursor, and the first parameter was input table. We talked about that. The second parameter is the field names that you want to include in your cursor. You don't have to include everything in your cursor. So one thing that's helpful is to only include those elements that you want to include in your cursor. You can use a star instead of a list of fields, okay? But it says here, for faster performance, reliable field order is recommended that the list of fields be narrowed to only those that are actually needed. An important thing about this is, I said we're going to talk about raster next week. Raster fields are not supported, so we're not dealing with raster data. However, you can still, if a raster has a table, you can still read it into it, but it'll just be like a table that doesn't have any geometry information associated with it. Okay, now your shape field. What's going to come back from your shape field? You actually have several options with this particular cursor, and all the cursors are the same or very similar. You can get a number of different things. You can get the XY of the centroid. You can get what they call the true centroid. I forget what the difference is there. One is guaranteed to be within the feature, and one isn't. I forget which one's which. I'm pretty sure the centroid is the one that's guaranteed to be within the feature. The true centroid is simply the weighted average. So you can read the help on there. It's not really important here, or it's not something that we're going to go over. Okay. You could just get the X coordinate. You could just get the Y coordinate. You could get the Z coordinate, because in ArcGIS, I know we originally said it's two-dimensional, and most times it is, but sometimes there's a Z coordinate associated with it. Okay, let's say it's LiDAR data, light detection and ranging data. There might be a Z coordinate associated with it. Okay, the M coordinate is another set of coordinate information, and that's included in there because at some point somebody thought, well, we've got an X, Y, and a Z. Wouldn't it be great to have another coordinate that might represent time or something else? Okay, it's rarely used because as an alternative to an M coordinate, you can just have an attribute, which people could actually see in the database table. So more often, that set of information is included separately. But you do have the ability to store up to 4 coordinates for each point: X, Y, Z, and M. All right. Now, those are all having to do with either points or they turn into points. So what I'm trying to say is, if you say, okay, I want to see shape at X, Y, and I feed it that field name. If I have polygons, I'm going to get a point that represents that polygon. I'm not going to get the actual representation of the polygon. That makes sense? Okay. From here on down, you're actually going to get the representation of whatever it actually is. Okay. Well, all the way to here. I should say, actually, all the way to here, you're going to get a representation of what it actually is. These are also summaries. This will return the area, so it won't even return a geometry. This will return the length, so it won't return the length. I mean the geometry itself. Okay, so shape at JSON. We're going to talk about this a little bit more next week, but JSON is one type of string representation for the geometry, and we'll print this out and show you. It's very similar to what we know as a Python dictionary. It's a format that was developed for sharing information on the web. So it's a neat little format. We'll talk about that. WKB is an open standard that's a binary format, so you can't really read it. WKT is well-known text. It's also a open standard, but it's a text format. And we'll demonstrate both of these here real quick. And then finally, we've got our shape, which will return a geometry object. This is very common to actually return the geometry as an object. Then you could start messing with that geometry. All right, so let's implement this on the. Let's first do it with the this GPS points data, and then we'll do it with the parks data and see what happens. So let's open up Python. And if we go into, if I go to new window, and I'm going to say, okay, I'm going to save this as, I'm going to save it in the directory for the course so that I can upload this later. Week 7, I'm going to call this example 1.py. All right, so I've got to import ArcPy first before I can do much of anything. Okay, and then the next thing that I want to do is create a search cursor for this data set. And so I type in arcpy.da.search cursor. Did I spell cursor right? I'm horrible at spelling. That's why I like to copy and paste from the help a lot. Probably said that before. Okay, so the next thing that we need to do, just like when we were operating with, like when we wanted to run an operation, we want to do an intersect or an overlay of some sort or a buffer, we had to feed it a string. Same thing, we need to feed it a string here. It's the string representation of where the, sorry, that's open from last week, of where the information is stored on disk. So in my case, it's ctemp data. Oops. Ctemp, that's just not working here. I'll go like this, that'll work. No. Did I put it there? It's fine, I put it in ctemp data. No. Here, I know another way. So we'll look at it in here and source. Yeah, that's where it is. Copy that. And look here, copy that. Put that little R in front of it so that it doesn't treat your slices weird. And then for now, I'm just going to put star. Okay. All right, let's go back to the help real quick. Cancel. And look at that information. There are a few additional things that we can enter. Okay. One is that we could enter a where clause. In other words, what if you only wanted to see some of the information? What if you only wanted to see like if you were doing states and you only wanted to see states that were in a certain region and you had a field that represented regions? Well, you could put that in there, and then your cursor would only contain those data sets that had those information. Okay. And then spatial reference, you could actually change the coordinate system that your geometry is going to come back in. That could be useful if you need to match it to another one. Here's another one that says explode to points. If you wanted to get the points that represent your geometries, you could use that. And then finally, an SQL clause that Oh, well, we're not going to cover that right now. Okay. So, advanced topic there. So if I just, right now, if I just ran this, it would work. I'm gonna assign it to a variable. Say I'm gonna call it rows. That's pretty common in the help to call it that. If I just say print rows, I'm gonna run it, and it will tell me that it's an object, just like it's done lots of times before. So it's telling me that it's a search picture object. That's not very helpful. I need to find out what's in there. Let's see what happens if I say for row in rows. It seems like that would be a Python thing to do, is see if it has the ability to be looped through like any other thing. And yes, it does. You see that? It ran and it created that information. So I've got the information there. It's 0, and then I've got a number here, and then I've got a 1 and a 1. Let's see if this correlates to the attribute table in any way. Let's open up this attribute table. So I've got 0, something, 1 and 1. 1, something, 2 and 1. It's exactly what showed up here. See that? This information is what's in the file. So now I can manipulate that. What if I wanted to do something like find out the average of a particular column? Okay, I could do that because, first of all, what is this data type that it's returning? What's that notation? A parenthesis with things separated by commas. What's that data type in Python? You say a list? You're close. It is a sequence that we talked about. It's a tuple, exactly. And what's the difference between a tuple and a list? What's the big difference? Right? Oh, we can change the values in a list. We can't change the values in a tuple, and that makes sense that this is read-only, so that makes sense that we can't change the values. Okay. What do you think the center number represents right here? And notice that it's also a tuple, right? Okay, what is that tuple? The x and the y. It's not latitude and longitude because those numbers would be, way. Those could only go between 0 and 90 and negative. In one case, negative 90 to 90. In another case, 180 to negative 180, depending on whether you're going this way or this way around the Earth. But yes, they represent the coordinates. Those represent the coordinates. These represent the other features in there. Okay, the other values. So if I change this up, let's say I want to change it up so that I don't want to get everything. I just want to get a field. I know one of the fields is called animal. I can run this, and actually that might not work. Just a second. I need to give it a list of fields, not, okay, it worked. It understood that. But this would be better. I believe this will still work. If I do this, that's a list of fields, right? Notice that it still returns the tuple, even if there's only one element in the tuple. See the tuple there? And so if I wanted to get the data out of there, I would still have to do that by doing something like this. Now, if I change that, I get the value out of that tuple. So I don't, let's say you don't know what the animal field is, but I could find out what the average value in that animal field was by simply doing something that we've done a lot of earlier in the course. I could say, total equals 0, and then say total plus equals row 0, and say print total divided by the length of, see if that works. I don't know if it is going to work. Yeah. So this length operator, even though it had a way to be iterated through, in other words, we could go through it using a for statement, it still doesn't have a length operator, and we don't know what that length is. And so it would be better to just say count equals 0, and then say count plus equals 1, and then just now it's going to go through the loop. Let me put this over here. And this time, it's going to find the total, and it's going to find the count by doing this operation, and then give us the mean. I could return all of them. Total count. So now I am returning each value. So you see the total of the animal field is 188. The count is 43. In other words, there are 43 rows, and the average value was 4. Okay. The average value in that field. Okay. And so that's looping through a data set. So there's all sorts of applications for this. Let's say you wanted to, you had a job where some of your GIS data was dynamically changing on a weekly or monthly basis, and you wanted to write a report and report what the average value was now. Well, that's a simple, quick way to do it, and it actually operates faster doing it this way than it would to use the tools, because I realized you could use tools in a toolbox to get to a similar result. It wouldn't be exactly the same, but it would take a lot longer to do in a toolbox to summarize a field, and you wouldn't get a single number output like this. So this could be something that you saved out to a file that could be live to the internet, or that your boss could look at, something like that. Okay. So that's the ability to look through those data on disk. That's a good idea. Sun's gone down. It's not going to get any warmer here. Don't have to yell so much. Okay. Now let's look at some of these other ways that we can manipulate the shape field. A lot of these won't make sense for a point data set because they would be the same. If I said shape at XY, I'm going to get the exact same value. Is if I get the true centroid X, then these would make sense. But let's look at some of these others. Shape at JSON and see what happens. It actually stands for JavaScript Object Notation. I don't think I said that before. But in addition to the animal field, I want to get, actually, before I do this, I'm going to save this as example 2 because I'm going to mess up this a little bit. Example 2. Save. So now I'm going to do shape at JSON. Now row 0 is going to be that shape at JSON. In fact, to make it so this still works, I could put this. The order doesn't matter here. This is going to be the order that you get the data in. So it's not the order that the data is on. So that's kind of nice because you can change the order of the fields to whatever suits you. So in this case, if I do it like this, I'm going to, this will now be row 0, and this will be row 1, okay? Row number 1. And so let's print that. Let's report that. Print row 1. That's what I mean by that. So I'm getting the first row. This is the first feature. I mean, sorry, the first, not the first row. I'm getting the first column of every row. Because each time I go through this, row is going to be the next feature in the list. the next feature in the cursor is what I should say, because list has a meaning in Python. So the next feature in the cursor. But a cursor you could think of it kind of like a list. It's got the ability to be looped through each time. So here, look at this. This is the string that it returned. It returned this string for each one. See that? It's got a squiggly bracket. So it's going to be kind of like a dictionary. And if we go all the way down here, we've got the two squiggly brackets that close it. So it's got a string. It tells us the X. It tells us the Y. It gives us a spatial reference. And then it has another dictionary inside of that tells us what spatial reference it is. All spatial references that are standard have a number associated with them. Okay? And in that way, we don't have to store. What is a spatial reference, first of all? So when I say spatial reference, what do I need to be able to define a spatial reference? You probably learned this in one of your other courses. But I need a description of the shape of the Earth, right? I need a datum, and I need information about how the Earth is tied to a particular projection. A projection is a flat piece of paper, okay? So I need information on how that's tied. There's a fair bit of numbers associated with storing that information. So if I had to store that information in every data set, it would make those data sets larger. And so only if you're storing a custom projection does that information need to be stored. Otherwise, it just stores what we call a WKID. It stands for a well-known ID. So this particular number can be tied to a database of coordinate systems. We're not really going to be concerned with coordinate systems today. I'm just telling you that that's why it doesn't store the all of the projection information. It just stores a number. Okay. All right, so that's the data as a JSON. I could, if I wanted to, use this statement called eval. I don't know if we've done this before. Actually, before I do that, I'm going to also print the type of row. What do you think I'm going to get when I do that? What does this look like it is? Looks kind of weird. It looks kind of like a dictionary, right? Could be. Let's see what it says. It is a Unicode, so it's a string. Okay, remember it's a special kind of string called a Unicode. So it's not actually a dictionary, but it looks just like a dictionary. And in fact, the way that I could turn it into a dictionary is to use the eval keyword. Eval row 1. This is a function that returns the result of a Python statement. Since this is a valid Python statement, okay, this is a valid Python statement because it's a dictionary, but it's not a dictionary until you turn it into one. So that's what the eval statement does. So I'm going to run this, and you'll see that it makes it look a little different, but it's still the same information. Let me show you what I mean. So what do you suppose this will do? Actually, here, I'll do this. I'll say row geometry equals, let's say, and row geometry x, row geometry y. On this guy, and it's going to print the x and the y value. Okay, because if we look back up here, okay, we turned it into a dictionary, and all we did was say, I want this attribute and this. I used those keys inside that dictionary to get these values. So first I had to take what was a string and turn it into a dictionary. And then I printed X and Y from that. So here's an example of what I'm talking about. So if I set eval quote 5 times 3 using the eval keyword, but I'm passing it a string, well, that string is valid Python code. So the result is going to be 15, even though it's even though I passed it as a string, it actually interpreted it as code. So that's what that allows you to do. So if I did something like thing's not defined. So it's telling me that there's nothing in that code that's worth anything. Okay. So that's what eval does. It just takes a string and turns it into code. And so that's what this did. Okay, now that wouldn't be super useful for this because there's already a way to get the data in as an object. We don't have to use the JSON format to do that. But that's what JSON does, is it allows us to get the data in a format that can be read by Python. All right, so we've got a few other options here. I'm going to do the WKT, and then none of this other stuff will work, so I'm going to say this is example 3. Got example 3, and I'll have to delete this guy and print. I'll just print that row. So this is a different text format. So JSON is one text format that's used by a lot of people, and WKT is another text format that's used by a lot of people. So this format is a little less verbose, but you can see that it still has point and X and Y value. Right? So that's a way to get at the individual data. Okay. All right. And then actually, before we move on, why don't we see what this looks like if I say parks. Shape. It's gonna give us a fair bit more information. There's only 2 rows in the parks data set. Oh, but there's no animal column. So I'll just delete this and say name, I think is the name of the other column. But it's not going to let me add up those data. So let me just delete all this stuff. Delete that. Is it running or did I not run? Yep. Okay, so I've got 2 polygons there, and these are the shapes from the polygon. So we see we've got 2 polygons, and you'll notice that this one has 1, 2, 3 parentheses, and this one has 1, 2, 3 parentheses. Okay, but they break out in different places. So here's those 2 parentheses. Here's 2 parentheses. And here we've just got 1, 2, 3, and the 1, 2, 3 that close it. So this is made up of a single polygon, and this is made up of multiple polygons. Okay. We could also ask for the JSON representation, and we're still going to get all the same data. It's just going to be a different format. So we've got the rings. And there's actually several rings inside this one. There's only one in this one. Okay. It's less common to manipulate or to ask for the data from a polygon data set, but you still have the power to do it. Okay. With the point data, you might do something like calculate the centroid or calculate the distance between 2 points or something like that. With polygons, there's still applications, but they would be more complicated because you'd have to be sorting through all this information in here. Okay, so I think we're good on the search cursor here. Talked about search cursor. One thing that we could do, one thing that I do want to show, let's go back to the Python. Too many windows open. And let me just go back and open up example 2 again. Close this one down. Okay, so I've got example 2, which is the GPS points. Okay. One thing that I wanted to do is, I'll say this is example 5. Example 5. One thing that I want to show you is that we have the ability to put that SQL clause in there. Okay. So I'm going to here delete all this, delete this, and I'm going to say print row 0, which is the animal row. Let me see if these show up in order, and if they do, then I'll have to change something. 4, 5. No, they don't show up in order. We got 1, 3, 2, 5, 4, 6, 9, 8. There's some that are out of order. So I could say right here in my where clause, I could say something like, I gotta look at the syntax because I forget. It's the same thing as building a query. I'm pretty sure that we just put it in quotes, but it's different in different data sets. It looks like it's just in quotes. So let's say, and then this would have to be animal. Now if I run this, I should, oh, I don't need to put this in quotes because it's a number. I was putting because it was doing state name. But now I'm just going to run this. I'm only going to get those records that have an animal equal to 3. See that? 333. I only got those records. So that's a where clause, and you just have to be able to know how to formulate that expression. And if you need help on doing that, one of the ways that I find is to pull the data up into ArcGIS and go under select by attributes and use the GUI to type it in, and just take that text and copy it in there. So if you don't know how to formulate the query for your particular operation, that's what I'm talking about. So you could go into selection, select by location, or sorry, select by attributes, and say animal equals 3. So that's how I got that number. All right. Okay, and then finally, go back. What if I want to change the order? Okay. I can do that here. Oh, okay. This actually isn't going to be available. This isn't going to be available here when it's a shapefile. See, so I was going to demonstrate this, but you could also use an SQL statement and say you want to order it by the animal field. You could do that, but you can't do that in this case. All right, because it's a shapefile. It has to be a geodatabase. Other sources do not support that. Okay. All right. Okay. So that's the search cursor. Search cursors allow us to go through data and look at the individual information. What if we wanted to add data to an existing data set? That would be an update cursor. An update cursor allows us to, what if we wanted to change the data in a data set, but not add any new rows? That's an update cursor. So we don't want to add any new rows, but we want to change the values in an existing table. That's an update cursor. Okay. So that's the next one that we should talk about. Here's the example. Here's the example that the book has. Let's see what the book, the online help is. Let's see what it's doing. Okay. First of all, it's asking for a workspace and assigning that workspace that we've done before. Then it's getting a roads data set, and it's getting a road type and a buffer distance. And what it's going to do is loop through for each row in our cursor, and it's going to take the row and multiply it by 100 and shove it back in. So it's a pretty simple routine. It's just going to take the value in a certain field and increase it by 100 for a field. We could also use it for model. Let's say we had a whole data set that somehow we collected, and this has happened to me, somehow we collected it and we were off by like 5 meters in the X direction or the Y direction. We could use an update cursor to move everything over 5 units, 5 feet or 5 meters, whatever our data set was in a certain direction. We could do that, and that's something that update cursor would allow us to do. Update cursor. We won't demonstrate that. An update cursor works very similar to what we're going to talk about the next one, the insert cursor. The insert cursor is for creating entirely new rows in a data set. So let's say I have an empty data set and I want to populate it, or if I have a data set that I want to add rows to, those would be scenarios where I'd use an insert cursor. And we're going to actually do this as a part of the lab today. And I think I'll just demonstrate that as we work on the lab, the insert cursor. So let's put that away for a few seconds. Okay, but before we do that, I want to look at geometries themselves. So we talked about looking at them in a few different text formats, but if we just want the geometry itself, we can do this. So here is, I'm going to leave this animal equals 3 because I don't want to get all of them. Okay. And I'm going to print that one, run it, and it's going to print for those 5 or 6. It says it's a geoprocessing described geometry object. Okay. So let's look at the help here, and if we look under geometry, I'm just going to type in geometry here. I should have put the link up. I'll put the link up later. We look at geometry. Oh, that's way too much information. So I'm not going to get us the right places. Let's just, I know where to find it in help. Okay, so the shape geometry object, if you just click on this little thing, it'll take you to the help for a geometry object. Okay. So these are the ways that we formulate and work with geometry. Geometry can take up, it can be points, it can be multi-points, it can be polygons, or it can be polylines. So in most vector models, those are the options. A point geometry is just a plain old set of points. Multi-point can be multiple points in the same row. A polyline can be one or more lines in the same row, and a polygon can be one or more polygons in one row. And if we have a polygon, we can actually turn it into a few of these different properties. We can turn it in, we can turn it into JSON. We can turn it into well-known text. One thing that we could do is we can actually inspect the individual components of our points, lines, and polygons, or we can build them. Okay, we can read geometries and we can write geometries. So let's practice really quick reading the parks data set. Okay, we're gonna read through that geometry and find all of the information contained in that geometry. So that's what we're gonna do here. So let's go back. I'll call this example 6. Here in this example, we're just reading a points geometry, which is easy to do because there's just one per each one. In fact, if we wanted to get that data, I think it's just like that. Let's see what this does. Nope. Okay, let's go back to the help here, and we'll look at what a point geometry, because a point geometry is an object of a particular class. And so this is the information that that class has. Okay, it has a centroid, it has an area. For a point geometry, I'm sure that the area is always something that's not even useful, but let's find out how many. Let's get the latitude and longitude. Well, we could just ask for the centroid, because the centroid of a point is a point. So if we said centroid.x, pretty sure that we're going to get the values. Centroid.x, it's a capital X. We're going to get the x values for that point geometry. Okay. We could also get the y values. Okay. So it's easy to get the x and the y values for a point geometry. Even this point geometry, though, is technically a multi-part geometry. So what we want to do is build up to start getting polygon geometries. Okay, we want to get polygon geometries, and we can use these same operations. Here we've got we've got part count. This will return how many parts each geometry has. How many parts do you think each of these geometries has? It'll be 1, because it's a single element. It's just one point. So if we want to get the individual pieces of that geometry, we can get its parts. There we go. And that is in here. I'm just going to search for it. Get part. We can say row 1 dot get part, and then we know that it only has a single part, so we just say 0, and we want to find out what that is. What is that particular part? Run it, and it's going to tell us that it's a point, basically. It's a point. So we know that it's a point now, and so instead of getting the type, let's actually get the X value. So just like the centroid was a point, we know this was a point, and we have its individual values. It's a class. It's an object of the class point. So we have those X, Y values. And here I'm just showing the X values. All right. Now, if we change this so that we're no longer getting I'm going to delete this, and I'm going to change this to parks. So we're no longer getting the points, we're getting the parks. We're going to run through this, and let's see what it does. Okay. Now it says that you have an error. Okay, your array object has no attribute X. An array in computer science actually has a meaning that means that it's a set of numbers that are together on disk. Okay? In this case, it's putting array in quotes. It's what ArcGIS calls it. So remember that a polygon is made up of points. There's not a single point. So if we look at what a polygon is made up of lots of lines that are made up of lots of vertices. Okay, that's the order. And so a point feature is made up of lots of points. So when we said to get the first part of our point features, those were points. When we say to get the first part of polygons, those are groups of points. And ArcGIS happens to call them arrays. So it's an array. So that's why this doesn't work. However, if we just said this, just typed that line, it would report to us what the first part was. So it's an array object is what it's calling it. And we have to go back to the help in order to find out how to deal with those array objects. So we go to geometry, and we go to polygons. Okay. And coordinates, these data types can be either points or array objects. It's going to return an array. Get part returns an array of point objects for a particular geometry. Now, an array object is, like I said, a group of things, just kind of like a table or a list. So let's try saying, let's just call this part. Let's try just doing this. Say point for, I'm going to say PT in part. Print PT. The beauty of Python is that lots of times, if there are groups of objects, the for statement will work. Okay. So that's what happened here. Is we said, okay, for every row in our attribute table, print off, or we didn't print them. For every row in our attribute table, give us the geometry. That's what we did here. So this is the geometry. In that geometry, give us the first part. And then in that first part, we're going to print that part. And we're printing it here. Okay, we could print just the X value. I think it's capital X. Instead of printing all the values. go like this. So we're printing just the X values or just the Y values or whatnot. Okay. I'm going to say print PT. And when we do that, what we have here, this is the same thing that's up here. This is X, this is Y, this is Z, and this is N. So those. Okay, so let's change this so that instead of giving us the instead of giving us just the first part, giving us all the parts. Okay. So let's look back at the help, and we've got our part count. Okay, and so it doesn't look like there's a way to index through the parts. So the way to do that would be to say for part in row 1 dot part count. That'll give us the count. In fact, let's before we get too much further, let's comment out this and see what that produces. What do you think that's going to produce? Print a 0 and then a 1 because we have two parts in one of them, or it should print a 1 and then a 1. Okay, the int object. Yeah, sorry. But they changed Python syntax. It's just like this now, right? Okay, so the first time through, there's two parts, and the second time through, there's a single part. Remember the polygons that we made? Am I not spelling part right? Let me see here. Instead of this, I'm just going to go like this, Control X. See if that's my issue. What I'm trying to do is loop through each part in the part count. Two and one. That makes sense. Okay, so see if this works. All right. I don't know exactly why that statement doesn't work, but what I'm trying to do is loop through each of the parts in the part count. Loop through each of the Oh, I know what it is. Sorry. There we go. So I used the wrong kind of brackets. Yeah, it happens, right? There we go. All right, so the first time through, it's going to loop through and it's going to go through twice because it's going to say 0, 1, and the second time through it's just going to be 0. Okay, because the first one has two parts, so it's going to go 0, 1 in that range. And the second time through it just goes 0 because there's only one part. So instead of saying part row, I'm going to do this. I'm going to say get part number. And finally, okay. This is the code that you would need to do to loop through every item in a geometry that's a polygon or a polyline. So it's a polygon or a polygon, you would need this code to get every single one of the XY location. So this is every vertice that there is. So that's every vertice. And here it's telling you which part it is. So this is part 0, and then this is the coordinates associated with part 0. This is part 1, and these are the coordinates associated with part 1. This is part 0 of the second object, the second row, and then this is the data associated with that. In fact, if we wanted to say row number equals 0, we could do something like this. And I'm going to remove this statement. Actually, I'll just go like this, print and Python will yell at me if I don't convert them to strings. So I'll do that. And str. So what's happening here is that I'm just printing out this information so that it makes it easier to see. So that we can see the individual components of a polygon or a point database. All right. I was going to try to cover. I was also going to try to cover doing spatial operations with an individual components, because we can do that. In fact, I'll show you the help, but I'll cover that next time we meet. That way we don't cover too much in one day. But see how you can actually take two different features or one feature, and you can buffer it, you can union it, and it's different than doing the spatial operation. In fact, it performs better for an individual result, but as you magnify that up, it's better to do it. So if you're going to do a union of 1,000 features, it would be better just to do it as the operation union in ArcGIS. However, if you're just going to do those features and there's something that you need to change individually with each feature, you could do it here. So you can find the difference between two features and so on. But we'll save this example for the next time that we meet, messing with the individual features. But there's all sorts of cool applications. Maybe I'll show one of those when we get back from the break. But here, with this information, we've read the items out of a database. Out of the data set. Now we're just going to reverse the process to get those information back in. What we're going to do for the lab is take a series of points and shove them into a line file that represents a track. Okay? So it might be something that you would do in a job that you would have. Okay, so we're going to reverse this process, and we'll start that in the lab so that you'll at least have something to work with in the lab. I'll just demonstrate it as we go in. So that's when we'll use the insert cursor. All right, so let's come back. It's about 45 after. We'll come back right at 15 minutes, right at 7 o'clock, and then we'll demonstrate insert cursor by starting the lab. All right. It is getting a little bit warm in here, so I'm gonna turn the air conditioner on during the break, and then come back to that. Somebody remind me, but I'm gonna go ahead and and stop this and restart